Hello everyone, welcome to part 2 in this video series where we are looking at building a power or energy monitoring system using an Arduino. If you haven't seen part 1 of the video yet, then I recommend doing so, and I'll try and do that thing where you can embed that into the video and you get to click it. I've never done that before, so that'll be exciting for me. But what is it that we need to complete this project? Well, I say complete, to start this project. Well, we need an Arduino Uno. I guess you could use any Arduino, it doesn't have to be an Uno, but I've got an Uno here. We need the SD card shield and real-time clock shield. I mean, you could do it with separate components. So you've got the real-time clock here and a mini SD card reader. You could do it with that, and there's plenty of videos online that show you how to do that. You also need a CT clamp to measure the current. There's our CT clamp with our cable. We also need, in this case, a voltage regulator, and I'm going to use a buck converter, which is this thing here. It's a, what is it, an LM2596 DC-DC buck converter. I'll have a look at that in more detail in a bit. And I've also, well, we need a voltage divider circuit, and we need a way of getting this current measuring device onto the board. So I've created my own little prototype circuit board here, and we'll have a look at this in more detail in a bit. And well, when it comes to it, we'll have a look at it. Right, what else do we need? Well, things like a voltage source. We don't need a house plant, but we've got one of those as well. So we need a voltage source. Actually, we've got two voltage sources here. We've also got a DC power supply, and I've got a 12-volt battery as well. We need some fuses. We need some connectors to get the fuses. I've put a switch in as well. I like putting a switch in. I'll tell you why later. So a couple of these connectors as well. So that's all we need. So let's just get on with it, shall we? Well, the first thing we're going to look at in this video is this buck converter. Let's just move everything else aside. Quite like the lighting today. It's got a lovely sunset happening at the moment. Be hard to see. I'll try and show you actually. Oh, my windows definitely need a clean, don't they? But anyway, that's not part of the video, is it? Buck converter. Let's have a look what's going on here. Well, we have a 12-volt battery. And what have I done? I've put a fuse. I can't remember what size fuse is in there. I think it's either a 200 or a 500 milliamp fuse. And I put a switch on it. That's connected to the positive terminal. And then what I've done is solder it in. So solder a cable from the battery, and then solder another cable which provides our little jack connector there, and the same with the negative as well. So the first thing I'm going to do is measure the voltage of the battery itself, and there's a good reason why I'm going to do that, which we'll find out now. Let's measure the voltage of the battery itself, and what have we got here? 12.5 volts. Great. Right, so the battery's going to be out the shot now. Let's have a look at the buck converter itself. So if I turn on the switch, and I measure the voltage, and I put these little connectors on, these little crocodile connectors on to the buck converter. I turn on the switch. It should be measuring 12.5 volts. Fantastic. What about the other side then? So turn to the other side. What am I getting here? I'm getting 11 volts. Okay, great. Well, you can easily change this by altering this pot here. So if I turn it clockwise, the voltage increases. But I get to a point here where we're at 11.9 and that's it. No matter how much I turn, we can't go up anymore. All right. Because there's got to be some differential, isn't there, between what you're trying to regulate to. So we've got 12.5 volts in. The most we can get here is 11.9, and I just said that on part 1. I thought that might happen, but that's okay. This is absolutely fine. Let's take this down to, I don't know, I'm just making it up now. Anywhere between 7 and 12 volts is fine. So let's take it down to 10 volts. There we are, something like that. Right, so that's our buck converter set. We've got 12.5 volts coming in, 10 volts going out. I'll remove this. So if I now put obviously I don't need to do this, but I will do it just to satisfy myself. If I measure the voltage on this jack here, there you are, 10 volts. Fantastic. So now I'm going to turn the switch off here, and I'm going to bring in my Arduino, and I'm going to plug it in. There we go. My Arduino plugged in. Switch it on again, and bang, there we go. I've got 12 volts. Well, yeah, I've got 12 volts going in. Next thing I'm going to check, actually, while I'm here, is I'm going to check that I've got 5 volts out on the 5 volt out pin. So here we have our pins. We'll put a ground pin in here, and then we'll put a 5 volt pin in here, and make sure they don't touch. Classic. And I'm going to check to see if we are actually getting 5 volts out of here. We should be. There's no reason why we shouldn't be. Bring in the voltmeter. Yeah, 5.018 volts. So that's good, because that's going to provide the power to my CT clamp, basically. So I wanted to make sure we get that. Let's remove these. Alright, right, next stage. Right, I've disconnected my Arduino for now. Next thing I'm going to do is talk about this. This is my little board that I've made. And excuse the soldering, because what I should have done is use these, which actually arrived in the post today, but obviously I was too eager to do this without these. These have got very long pins on them, and what I should have done is use these to go through the board, and then that would have provided me with long pins then to go straight into the Arduino, but I didn't. What I did was I used a male header here and a female header here, and obviously these pins, these are the pins that go into the Arduino, and these are the pins that just stick out the top there. So you can't really put your female header on top of that. So what I had to do, or what I did do, if I just waited a bit, or I just sort of, I don't know whether you can see that, I basically soldered some wire from these male output headers, made a loop of wire in there, so you can just about see that, and then soldered them on the other side. So what did I do? Yeah, I soldered them on the other side to the female pins there. So I'm going to take this back to the PowerPoint presentation and show you how I did that. Alright, well I decided that this video is long enough as it is, and going through that voltage divider circuit is quite in detail on its own. So I'm going to put a link in the description, or I'll have one of those thumbnails that come up, and that will link you then to me explaining in detail how I made that voltage divider circuit along with the CT clamp input. Okay, on with the rest of the video. But I guess the biggest points to note now is this is our voltage divider circuit. You see it? We've got our resistor, R1 of 33k, and we've got our 5.1k here, and we've also got the V out here. This is our V out, which is obviously, now if we look at it here, our V out is here. Is that right? Yeah, I think it is. Then that's going into analog pin 1, I believe. The other thing we got in this circuit is our input for our CT clamps. This is our negative input, I believe. Yeah, that's connected to the negative section of this board. And this is our positive, this is our plus 5 volts, and then this is our V out, which is going to our A1 pin. Alright, so that's that. Okay, so what am I going to do with this? Well, I'm going to bring in this voltage bring in this power supply, and I'm going to connect this connect my board up to the power supply. Alright, I'm going to make sure the voltage is low to start with. Right, now I'm going to take this A1 out, or whatever it is, I think it's A1, and I'm going to connect up my voltmeter to that, my positive. Now I need to connect my negative to somewhere, so, well, I can connect it to here, which is the negative side of this resistor, this 5.1k resistor. And let's bring in my voltmeter again. Right, my voltage divider circuit. So what should I expect? Well, I should expect that as I increase the voltage here, then obviously the voltage is also going to increase here as well on the voltmeter. So this is my V in here. So at the moment I've got 2 volts V in, but I've only got 0.4 volts V out, which is fantastic. Now as I start to increase, I've got 5 volts coming in, I've only got 1 volt coming out. That's great. Let's keep on going. I haven't blown anything up yet. Now I've got about 17 volts going in and 2.5 volts going out. So this is working great. So when I measure my battery voltage eventually in the field, which would be about 26, maybe up to 28 volts, the Arduino is only seeing 3.6 volts, which is great. This maxes out, the input maxes out to 32 volts, and at 32 volts my output, my V out is 4.4 volts. So if I took this down to 30 again, that should equal about 4 volts, which it does, 4.1 volts, something like that. So my voltage divider circuit is working fine. Right, we've basically gone through all the individual components here, so let's have a look at putting them all together. I've already wired in my CT clamp here. I'm not going to put you through the arduous task of watching me wire in, putting some wires into some terminal blocks. Okay, so we've seen this numerous times. Arduino Uno, our real-time clock, and our shield, our data logging shield. So our SD card's going to go. I've already put the battery in. It's a, what is it? I've used a CR12203 3 volt lithium cell there. Now I'm going to put my shield on top of that I've made. Make sure it all goes in the right way. So I want my analog pins facing me. So we've got here, let me get a pointer. We've got A0, which remains free. A1, which is my voltage divider output, and A2 is my output from my CT clamp. Okay, so that's all put together. Now actually, if I power this up, I'll check I'm getting 5 volts then. Now if I power this up, I'm going to check I'm going to get 5 volts out. This is one of the last checks I'm going to do. So I should have 5 volts. I should have 5 volts across here. These pins, they are 5.0. And we measured that earlier. It's basically the 5 volt out pin here, that's directly connected to it. Okay, so that's working great. And that's it. That's my circuit complete basically. So I've got an input waiting here. This is my voltage divider circuit. So I'm waiting for an input there from the battery. I got my CT clamp here, which is wired in. And I've got my real-time clock with my battery in it. And I've got my SD card shield. So the question is then, what voltage am I actually going to measure? So I think what I'm going to do is, so I'm going to plug this in here. This is from the battery. So this is coming from the battery with a fuse. I think it's a 500 milliamp fuse in there. Got a switch on it as well. And I think I'll plug this into here, and we'll use that. We'll measure the voltage of the ledge. We'll not look at the ledge battery. The battery I've got there, the 12 volt battery. I think what I'll do is I'll use the current DC power supply here to provide power to a load. My load in this case is just going to be a reel of LED lights, and I think I'll put my CT clamp on this cable here, which will measure then the current, obviously being drawn by the by the lights. I could simply just run the lights off the battery, and that would be absolutely fine. But there's one thing I want to do is this DC power supply. It does give us a current measurement, so it might be good to do it this way, because then we can see, like, I don't know, some kind of accuracy between what we're measuring and what this says. But to do this next bit, we need the computer in front of us. So that's what we're going to do next. You know, I'm going to call that part 2. That's part 2. We've done a lot there. It's like a 16-17 minute video. So we'll call that part 2, and in part 3 we will hook this up to the computer, show you a little bit of the code, not all of it, and then actually test the circuit. That's what I want to do. So I'll call this part of the video like circuit assembly, and then the next part I'll call something like circuit testing or something like that. Alright, hopefully that was useful. I enjoy doing these. Leave a comment, leave a like, you know, all that kind of stuff. Because, you know, you just don't get to see these things otherwise on YouTube. They just disappear. Alright, ta-da.